Hello and thank you for watching my video. My name is Astrid Krasniqi. I'm CCNA and CCNP certified instructor. On this video we are covering CCNA semester 3 scaling networks, and this is chapter 9 iOS images and licensing. Chapter 9 is divided in two sections. We have section 9.1 managing iOS system files and section 9.2 iOS licensing. Section 9.1 Managing iOS System Files. Upon completion of this section, you should be able to understand the necessity of managing iOS image files to increase network reliability in a small to medium sized business network, and explain the Cisco IOS image naming conventions. iOS software trains. A Cisco IOS train is used to deliver releases with a common code base to a specific set of platforms and features. A train might contain several releases. Because different software releases families can apply to different platforms or market segments, several trains can be current at any point in time. This chapter examines the train of both iOS 12.4 and 15. Train. The iOS train is something like a major number if you think about conventional software. This is where the foundation of operating system inter-network operating system feature set is established. Cisco IOS integrated service router G1 and G2. As an example, here are some of the recent trains: 12.2M, 12.4T, 15.0M, 15.1T. Throttles. iOS throttle is roughly a minor version number where some new features and bug fixes may have been added. Again, using Cisco integrated service router G1 and G2, you can see there's some examples of throttle. For example, at 12.2 throttle 10, 12.4 throttle 20, 15.0 throttle 1, and 15.1 throttle 3. Rebuilds. iOS rebuilds typically consist of bug fixes. Adding new features to rebuild is generally avoided, but it does happen sometimes. Again, some example, for example, iOS 12.2, a major operating system, throttle 10, rebuild B. And then same for 12.4, throttle 20, rebuild 3, 15.0, throttle 1, rebuild 8, 15.1, throttle 3, and rebuild 2. From these values, it can be told that 15.01 M8 has been rebuilt 8 times. That means that there have been 8 rounds of bug fixes for this version of operating system. iOS 12.4 software packaging consists of 8 packages, 5 non-premium packages, which are, for example, start with IP base. This is entry level of Cisco Inter-Network operating system and includes something like IPv4. It can do trunking and DSL. Then we can add IP voice to that package. So you have everything that's in IP base, plus we add in the voice over IP, and voice over frame relay. Then we can choose advanced security, which adds security and VPN, or we can choose SP services, service provider services, which adds service provider services, SSH, SSL, ATM, voice over ATM, MPLS, or we can have enterprise base, add multi-protocol services. And then we have the 3 premium packages, which we have advanced IP services, which includes everything that you see underneath it, but doesn't include enterprise services. Or we can add enterprise services, which doesn't include advanced IP services, but it does include everything that you see underneath there. Or we can have the full Cisco IOS software, which is advanced enterprise services. That is 3 premium packages. Universal images. Cisco Integrated Services Routers Generation 2 or ISRG2 support 2 types of universal images. Universal K9, which images offer all of the Cisco IOS software features, including strong payload cryptography features like IPsec, VPN, SSL VPN, and secure unified communication. That's one type of iOS. The second type of image is Universal K9 _MPE. There is no payload encryption. Images that do not support strong payload encryption. This satisfies countries with import requirements. So some countries in the world, they don't allow such a strong encryption, so you can have this type of operating system in those countries. iOS 15 System Image Packaging. Devices shipped with universal IP base image installed by default. A license is used to enable the specific feature sets. So for all the devices in iOS 15, they will have IP base by default enabled. And these ones are there. All you need to do is you enable them by adding a license to it. So we have 4 types of images. We have IP base, we have security, unified communication, and data. The iOS image file names, for example, if we go to the router and say show flash 0 : that will, in there we will find an iOS. An iOS in Cisco is not like any other vendors with a name or anything. It's just like it defines a lot of information within the iOS. So first thing that what we see is the hardware. So C1900 is actually the hardware of this router. Then the image feature set universal K9. MZ means a memory location and compressed format. Most common designation for memory location and compressed format is MZ. The first letter indicates where the image is running from. So M means it's running from RAM. If it's F, it's from flash, R, small r, from ROM, and L, relocatable. The second letter specifies how file was compressed, zipped, to effectively reduce the size of the image. The compression format can be either Z or X, so Z for a zip or X for mzip. Images are self-unzipping, therefore, when loaded into RAM for execution, the first action is to unzip. Then major release. This SPA here is like is valid signature from Cisco. So major release is 15, the minor release is 2, the new feature release is 4, the extended maintenance release and maintenance rebuild M3, and then the file extensions is bit.bin. Managing Cisco IOS images. Images and configuration files can be stored on a central TFTP server. Backup iOS and configuration files can be used in case of system image in the other router becomes corrupted or accidentally erased. TFTP server allows image and configuration uploads and downloads over the network. TFTP server can be another router or workstation or host system. Rather than going through the slides on how to save the image to the TFTP server or running configuration, I'm actually going to demonstrate to you and do it on the packet tracer. So I'm just going to start a packet tracer. Okay, now the packet tracer is started. All I need is a router and I need a TFTP server. So one of these end devices will do. So this is the TFTP server. So if you look under the config, the services, it's got TFTP and it's on by default, and there's already some operating system there already. So what I'm going to do is I'm going to remove all of these, remove all of them, so there's nothing left, and I'm going to give this TFTP server an IP address, say 10.1.1.2, and leave subnet to default as is. Close this, connect the TFTP server to the router. Now the cable that I'm going to need to connect these is a crossover cable, or copper crossover, so fast Ethernet on the TFTP, and then on the router fast Ethernet 00. There we go. We have a connection. Now if I go to the router and I'm going to go to the command line interface and start configuration, let me just increase the font so we can see a bit better. So 16 will do. Okay, so on the router, go no here. It means that it's brand new router. There's no startup configuration. So enable config T, just change the name, host name R1, and then all I want to do is I want to go to that interface, fast Ethernet 00, give an IP address, 10, say 10.1.1.1, it was /8, so 000, and then no shutdown. That's it. Okay, so if I go back to my packet tracer, what we have here is, if I zoom in a little bit, what we have here, the IP address of the TFTP is 10.1.1.2/8, and the IP address of the router is 10.1.1.1. So 10.1. Right, like that. Now the first thing when we want to save the iOS or running configuration or startup configuration to the TFTP server, the first thing you need to do is you need to be able to ping that TFTP server. So if I go to the router and I'll say ping 10.1.1.2. That's my TFTP server address. Okay, so I lost the first packet, which is okay, it's acceptable that because of the ARP resolution, and I got 4 replies. Okay, so if I do it again, I'm going to get 5 always now because the ARP is already been done now. So to save the configuration to the TFTP server, first we need to see what we want to save. We can say show flash to get the operating system. So that's our operating system that we want to save it or back it up to our TFTP server. So the command to do that is copy flash to TFTP. So we copy from flash to TFTP. What is the source file name? Well, I want to save this file, so I'll highlight all of this, copy and paste. Right, that's the file I want to save it. And what's the address? Now is asking of TFTP server. I can put the name as well in here if I have a DNS setup, but I don't, so I'm going to put the address 10.1.1.2. Destination file name, see, is put in the brackets here. So if I'm happy, I can just press enter. But I don't want to just press enter. I want to actually write my name in front. So I'll write like this, asterisk backup iOS, like that, right? So I know that I did back up my iOS, and it's already been done. Now, if you do it on the real device, it will take a lot longer than this. Well, a few minutes. So if I go to my TFTP server now, I go to the services and access the TFTP. As you can see there, now I have a backup iOS already configured on my TFTP, or backed up iOS. So if I can do the same thing for my other stuff, like for example, say I want to copy or back up my running configuration. So copy running config to TFTP. Copy running config TFTP. Okay. I don't know why I didn't accept that, or maybe there was a spelling mistake. Okay, yeah, the G is missing there. So address of TFTP server 10.1.1.2. Destination file name. Do I want to call it R1 config? No, I want to call it asterisk R1, and then backup, and then you will put the date, for example, here when you took the backup. And it's already done because it's a very small file. So if I go to my TFTP server, right, that, and now you can see that I already have my backup running configuration. Cool. So for some reason, if for example you went to this router and say show flash, and you deleted the iOS here. Say you went in and by mistake you deleted this iOS. So I'm going to copy this and then say delete flash, sorry, delete flash, and then paste it. Delete the file name. Yes, I want to delete that. Confirm that. Yep, done. Okay, it says no. Oh yeah, because I didn't copy the C. Let's try again. So delete flash, and then the iOS. But let me just copy the whole thing. Okay, paste. Okay, so now we have deleted, because before, okay, there was errors, no such a file on directory, because I missed the C there. Okay, so if I say show flash now, I don't have the iOS. But it's good, I already have an iOS backed up on my TFTP server. So if I want to return it back from the TFTP server, I'll say copy TFTP to flash. Address of TFTP 10.1.1.2. The source file name. Now you need to put exactly how it says here. Otherwise it's not going to find it up, right? So I'm going to put them side by side so I can write it. Well, I'm going to paste it and just write some of it. Okay, so I've got in memory the other side, says this end bit. So I'm just going to go in the front and write what I did right earlier. So asterisk underscore backup underscore iOS and then underscore, enter. Destination file name. Well, now because I have a destination file name, I don't want to put the same as is. I want to actually paste it just the iOS without asterisk on front of it. So paste, already memory, okay, and it's copying it back. So now when I say show flash, I've got my iOS there. Right, so that's your recover, how you would recover from the corrupt or lost, deleted iOS. Okay, so let me go back to the slides here and go through now the slides. Okay, so example the network. This is what we're gonna see on the example. So now ensure that there is access to the network TFTP server by pinging it. So to verify there's a connectivity, verify that TFTP server has sufficient disk space to accommodate the Cisco IOS software image. You should have, because TFTP server, they usually have terabytes. Use the show flash command on the router to determine the size of the iOS image that you want to copy to the TFTP server, and copy the image to the TFTP server using copy, source URL, which is flash, the destination URL, which is FTP. So first thing we said, we ping. Make sure that there is connection between the router and the TFTP server. There's reachability. Then show flash to find out how much space you need on TFTP server. Plus here you can copy the file, highlight and copy the image, because you don't want to write it, you make a spelling mistake or something. Then copy flash to the TFTP. Source file name, here you can paste it or you can write it. You might do a spelling mistake if you just type it, but if you copy and paste it, you're sure to be fine. Then address of the remote host. It would be the address of TFTP server, for example 172.16.1.100 in this case. Destination file name, so you write down exactly how you want to save it on the TFTP server, maybe put a date on it, and then you copy it. Now to copy it back from the TFTP server to the router, so for example the new release, the iOS has been out there and you went and downloaded. This example will illustrate copying the Cisco iOS software image from TFTP server to the router. A new image file, as you can see, will be copied from the TFTP server. Then now we have an IPv6 address. So here first thing, we have downloaded our new iOS from the Cisco website and we have transferred it to TFTP server. We verify the connectivity of TFTP server because there's a connectivity between the router and the TFTP server by pinging it. We ensure that there is a sufficient flash space on the router. Here you have to be very careful because the router doesn't have that much flash. You might need to delete the old operating system, but before you delete it, make sure you save it. Copy the iOS image file from the TFTP server to the router. So these are the steps. So for example, the second step, we go here, we already downloaded from this web, and we have identified that we verifying there is a connectivity between the TFTP and the router. And now we say show flash to verify that there is enough available space on the flash for the iOS. And then we say we copy TFTP to the flash. The address of the router, the source file name that we got it from TFTP server, the destination file name, we don't change it here, and that's it. Now to load that, use the boot system command to configure the router to load the new image during boot. Save the configuration and then reload the router to boot the router with the new image. After the router has been booted, to verify the new image has been loaded, use the show version command. So for example, after we copy the iOS from the TFTP server to the router, we use the boot system, in the global configuration mode, we use boot system flash 0:// and then the iOS, what the iOS name we have uploaded, the new one, and then we say exit. Now we do copy running config to the startup config and then type reload. Once the router has reloaded, we type show version to verify that we have booted from the new iOS. If for example we made a mistake here, spelling mistake or something, then the router is going to go back to the default. It's going to try and load the first iOS they finds on the flash. If not, check the TFTP server. If it doesn't find any iOS in TFTP server, then it's going to boot to ROM1 mode. So the boot system command to specify the name or the location of iOS software to load. We have several boot system commands can be entered in sequence. For example, if you want to boot from the flash a specific iOS, then you say boot on the global config boot system flash and then the iOS name. To boot from the TFTP server, the command you can see there, or to boot straight to ROM, boot system ROM. Thank you very much for watching section 9.1, Managing iOS System Files. Please have a look at my other videos and don't forget to subscribe. This has been Astrid Krasniqi. Next video, 9.2, iOS Licensing. Bye bye.